All right, so welcome. Thanks for taking the time to listen to this Primus Wind Power off-grid webinar regarding hybrid systems. Here's all my contact information, so if you ever need to get a hold of me, or here's the number to tech support as well, where you can get a hold of Bo Colton, who's our lead technical support person. And if it's a specific technical support question or warranty question, he can certainly help you as well. So just a little bit of, real quick, real briefly, a little bit about Primus Wind Power. Primus Metals is our parent company, which was established in 1989. That's where our factory is, just outside of Denver, Colorado. They work in the aerospace industry with a precision metal manufacturing, and we are just an offshoot of Primus Metals. The manufacturing of the air wind turbine is out of that same factory. We have a section in the factory, fairly large factory in Denver, and so we're part of that organization, established in January of last year when Southwest Wind Power kind of left the business, and now we've taken over the airline. Company mission is about reliability, value, and innovation, so we want to make sure we have a nice, robust, inexpensive turbine. A few updates from the industry. If we are adding the AirX Marine, we did in January add the AirX Marine back into the portfolio for industrial applications, which I'll talk a little bit more about. We're finishing up a monopole tower design with the Smart Foundation, which is a special fiber reinforced foundation that we've developed with another partner, and that'll be coming out soon this spring. So that you can have another option besides a guide tower for the air unit. This will be an affordable UPS shippable monopole, so with no guy wires foundation. We are currently testing at NREL this hybrid solution concept that I'm going to explain to you here in a minute. NREL is the National Renewable Energy Lab in Colorado, and they have all kinds of wind turbines up there that they're testing, including ours. And the oil and gas market is a really expanding market, especially in Texas and North Dakota for the SCADA platform, which is it's a communication platform that they use on their wellheads. But quite a big market. They're using our wind turbine combined with solar. This whole hybrid concept. They decided about 2 years ago that that solar didn't work alone. Just solar alone really doesn't work, especially for places like North Dakota, West Texas, and so on, and so they're adding wind into this, which I'll explain more about. Whisper Line was sold to Luminous Renewable Energy. That was a Southwest Wind Power product. If you do have questions about the Whisper, I can get you in contact with the U.S. distributor, John McDonald. Some of your customers may have questions about the Whisper product, Whisper 100, 200, and 500. So you're welcome to utilize me as a resource to help you get in touch with the right people. The SkyStream line was sold to the SkyStream line. The SkyStream 3.7 was the grid tie turbine made by Southwest Wind Power, and it was sold, to Exeris out of Oregon, and they are manufacturing that turbine and providing warranty and support for that turbine. And as far as we know, Southwest Wind Power has discontinued all operations as of March 2013. Here's the turbine itself, so let's just talk about the parts and pieces. And Ben, I know you know this turbine well, so I'm going to just move quickly through this. But nose cone is not only there for aerodynamic purposes to push the laminar flow of wind across the face and the blade set of the turbine, but it's also there to help prevent the infiltration of water through the bearings. So it's very good to keep that nose cone on if the customer has a cracked nose cone or the nose cone is clicking on the hub. Obviously, we want to get that replaced. They're relatively inexpensive, so good thing to have replaced. This is the hub right here. There's two different hubs for the air. There's the Air 40 and the Air Breeze hub, and the Air 30 and the Air X hub. The difference between the hubs is the placement of the root of the blade, which is this part of the blade, on the hub. The 40 and the Breeze has one bolt and a simple placement that you only can put it on one way. The 30 and the X has two bolt holes, so that's an easy way to distinguish the hubs between the different turbines. All the turbines have three blades made out of a carbon reinforced fiberglass mix in a mold. and they are 46 inches in rotor diameter. All the turbines have the same rotor diameter. The blades just are a little bit different. We'll talk more about that. As you move through the turbine, here's the face, here's the stator right here, and then this piece right here, a very important piece of the turbine, is the control card and the rectifier. So the turbine actually produces in the stator wild AC, unregulated AC, or wild AC as we say in the wind business, and it then goes into this control card, which has a control algorithm and performs a lot of different functions. But also on this control card is the rectifier, which rectifies that wild AC to 12, 24, or 48 volt DC. This is the nacelle right here. That's the body of the turbine, the bearing set, the yaw right here, the yaw assembly, which includes the slip rings and the brushes, and 3 wires down to the battery bank, including ground. So very, very simple, direct DC. It is a DC turbine, direct DC to the battery bank, and it must see battery voltage for this turbine to work. So that is one of the things about the air unit, and it can't, for some folks, they really need to know that it needs to be connected to the battery bank for this to work. We hardly ever see this in an AC situation, just because, for a lot of reasons, but it's just not good to go with grid tie using this small turbine. People have asked us a lot about using the air turbine in a grid tie configuration, but we really don't recommend it. This is what you get when you get a turbine, the nacelle, the body of the turbine, the yaw. Here's the 3 wires, the yaw isolator pad, the 3 blades, the nose cone. This is the Air 40 hub, because this is the Air 40. This is the land version. So the Air Breeze is the marine version of the same turbine, but it's just basically the difference is it's got a marine coating painted on it, a little different nose cone, couple different parts, but very, very similar turbine. All the hardware comes with the kit. This is all you need to install the turbine on the tower. All you need is these particular components. When you're placing, just a little reminder to your customers, when you're placing this turbine in the tower, this yaw pad is actually inside the yaw here. You push the yaw onto the tower with the yaw pad, and then you lift up on it about 1/8 of an inch, and what that does is it isolates the turbine itself, the yaw itself, from the tower, which helps to reduce the vibration, and that way it's just surrounded by the yaw pad is really attached. The turbine is attached via the yaw pad to the tower, so helps to reduce the vibration coming off that rotating mechanical device. So just keep that in mind for installation purposes. Blade and the hub assemble is very simple. 3 blades onto the hub, onto the turbine itself. Use the jam nut with the Allen key, and then the nose cone just clips right onto the hub. Very, very simple. It takes less than probably 10 minutes to assemble the turbine ready to go onto the tower. The stop switch is included with every marine turbine, and that would be the Air Breeze and the Air X. And this is a single pole 3-position DC rated stop switch, and we call it a break before make stop switch, which means you're actually directly shorting the windings as you go from run to stop through open circuit in this position right here. So it's a direct short to the windings when you're stopping the turbine. The reason why we have a stop switch with every marine turbine is because there's a number of situations in the marine environment where you'd want to actually hit the stop switch, and those situations would be, as a few examples, would be a storm coming in like a gale or a squall, and you want to shut that turbine down to protect it. It will shut down on its own, but it's better to do a direct short to the windings through the stop switch than allow it to shut down via overspeed protection or regulation, which we'll talk about here in a minute. Also at night, if it's a high wind speed at night and that turbine is running at high RPMs, it could translate some vibration down tower into the deck and the hull of the boat, and that could cause the inhabitants of the boat to not be able to sleep through that storm because of some kind of vibration, depending on how they feel about it. Some customers will just say, let that turbine run. We love the power it's producing, but that's why we have the stop switch in line. I also recommend you have the customer buy a stop switch with the land units as well. Now again, they come with the marine units, but it is an add-on with the land units. But it's a good thing to have, because there are situations in a terrestrial environment as opposed to marine environment where you'd want to stop that turbine. Again, if you're gone from your off-grid cabin for a long period of time, over a month or two, and you're not going to have loads in your cabin, it's better for the turbine for you to hit the stop switch as opposed for the turbine to be stopped, because of the fact that the battery bank shows high voltage and it's in regulation, which means the circuit card has said stop sending energy to the battery bank because there's enough, the voltage is too high in the battery bank, and it'll do that automatically. But it's really better to use a stop switch, especially if it's for long periods of time, like a month or two. Also, there might be a situation where there's a big storm coming in, and you want to directly short the windings to the battery bank, and it's a good idea to be able to do that very easily by just hitting the stop switch, by pushing it down into the stop mode. So keep that in mind. I recommend it with all the folks that I talk to, so please keep that in mind. These are two other things that I recommend when you're installing a wind turbine in a system. Is a very simple analog amp meter. This is a fuel gauge amp meter. Very simple, no parasitic draw on this amp meter, as opposed to like a digital meter where you have a milliamp parasitic draw. Very simple to wire up and very, very inexpensive. This is a $25 part. And anytime you have a rotating mechanical device directly wired to your battery bank, you want to have an amp or a breaker, a fuse or a breaker in between. And so this is another very simple, inexpensive part that you can purchase with the turbine. It doesn't come with the turbine, but it's very inexpensive to purchase, and I recommend a circuit breaker between the turbine and the battery bank. This one has just a pop-out fuse. That's what this is right here. Very, very simple, inexpensive. On the side of the turbine, we'll go back and show you where this is. On the side of the turbine right here, if you can see right here, is the potentiometer. And I'm going to explain what that potentiometer is. It's just a screw on the side of the turbine connected to the circuit card. But also on the bottom of the turbine, and I know Ben knows this, Robert, but I'm going to just review that for you. On the bottom of the turbine right here, there's an LED light, which is there for troubleshooting purposes, and so the customer knows what's happening with the turbine. And so when this, and this is a question you can ask if the customer calls you and says, look, this is what's going on with my turbine, or if you just need to do some basic troubleshooting. If the LED light on the bottom of the turbine, and they can see this very well at night, and even during the day it's a little harder to see, but you can see it. If it's solid, that means the turbine is in operation and it's exporting energy to the battery bank. If it's blinking, that means it's in regulation, and that means the circuit card has said, look, the battery bank is full, and I'm going to stop sending energy to the battery bank. I'm going to go into regulation, and it'll slow down the blade set. It won't completely stop the blade set, but it'll short the windings through the circuit card, and it'll just slow that blade set down. It'll spin just a little bit, but not much, and that's blinking. If it's blinking really, really fast, like 5 or 6 times a second, that's overspeed protection. And that means it's really blowing hard, and the turbine said, look, to protect myself, I'm going to go into overspeed protection, and I'm going to short the windings again through the circuit card, and I'm going to protect myself. I'm going to just slow down and protect myself. And that happens, somewhere between 45 and 55. It's all depending on gusts and part of the control algorithm, but that happens at about 45 to 55 miles per hour of wind speed. So let's go back to the potentiometer now. So this is the potentiometer factory set point. And the potentiometer, what it does, it adjusts the regulation voltage. And so for a 12-volt system, it's 14.1, 24 is 28.2, for 48, it's 56.4. Basically, at this voltage, the turbine will shut down if the turbine sees that voltage. But it can be set, adjusted to within this range. with this change to the potentiometer. So if you turn an eighth of a turn clockwise for a 12-volt system, you're going to get an 0.56 more volts going up that factory set point. And same thing for 24 and 48. You can see the changes here. So in some situations where you have specific batteries that accept a specific voltage, such as like a sealed battery, a specific sealed battery, or even a lithium ion in some cases, they'll need a specific voltage set point, and the customer can change this. Most of the time, I'd say 80% of the time, 90% of the time, our customers don't mess with the potentiometer at all. They allow it to be set at this factory set point, which works for most situations. But if they do say, look, I have the specific battery or I have the specific situation, they can change it. Here's a caution right down here. Remember, by changing this factory set point, it will not increase the power output of the air wind turbine. Now, Ben worked for a while in Southwest Wind Power Technical Support, and Ben, you probably remember, the customers would call you all the time and say, hey, I want to crank up my potentiometer all the way, and I'm going to get more power out of my turbine. That's a common misconception. It's not the case. By setting that voltage too high, you have the potential of overcharging and damaging the batteries. So just something to keep in mind if your customers talk about the potentiometer. It's something for you guys as salespeople to be aware of. Air specs, just a couple brief points on this. It has a 5-year warranty. It weighs 13 pounds, a 46-inch rotor diameter. Here's the startup wind speeds, 7 miles per hour for the 40 and 8 miles per hour for the 30. There's a reason. I'll explain why this is different. It has to do with the blade set for the 40 and the Air Breeze, which has more surface area, but basic specs of the turbine right here. This is a little tower height chart. When you're talking to your customers, one of the questions often we get with wind is, well, how high should I put my turbine up into the air? How high should that tower be? And the reality of it is what we typically recommend with most of our customers who are in a good wind resource or decent wind resource is 30 to 45 feet is kind of pretty much what we recommend. If you go above 45 feet, it just costs more in wire. It's a bigger foundation. It's more pipe. And we don't even sell a tower kit that's above 45 feet. It's a 13-pound turbine that weighs, that's a 13-pound turbine that costs less than $900. And so it doesn't make a lot of sense to go up way high. As you can see by this chart, though, as you go up from the surface, you reduce the surface roughness so you get better laminar flow of wind as you go up. And from 10 meters to 14 meters, potentially at sea level, you have as much as a 20% improvement, and it goes up from there from 14 to 18. So you can see that the higher you get up in the air, the better that laminar flow, the more energy you're going to get out of that turbine. But when it really comes down to it, most of our customers, it doesn't make sense to go up much more than 30 to 45 feet just because it gets so much more expensive to do that in wire, in foundation, in pipe, and so on. So just have a conversation with your customers about that and keep that in mind. So sighting a wind turbine, there's this Griggs Putnam index. We also call it flagging. When customers go to a site, they can see actually by this Griggs Putnam index what kind of site they have, if their trees are bent over, if the tumbleweeds or the shrubs are pushed against the fence line, and so on. Something to just keep in mind when you're talking to a customer about siting a turbine. The biggest thing to remember is just have that turbine sited on the prevailing wind side of any building or any object that's going to cause a major turbulence. In most cases, that's going to be the building, the house, or the barn, or whatever. And so that's the biggest thing. And typically here in the United States, it's in the southwest direction. So keep that in mind. When you're on the water, like any turbine that's on the lake or the ocean or something like that, you're going to have great laminar flow. You see these horizontal lines coming across the water. That's zero surface roughness here on the water. Gives you really good laminar flow, as well as you're going up a hill with minimal surface roughness. As that airflow, as that laminar flow of wind flows up the hill, it actually starts to compress. As you can see here, those lines tighten, and it increases velocity of the wind. But again, right here might be 200 or 300 feet from the house. It may not make sense to spend all the money and wire and so on to get that turbine up on the hill, especially with a micro turbine like the air unit. If it's a larger turbine like a Skystream or a Berge or something like that, sure, that might make sense. But with this air unit, probably doesn't make sense. Here in this situation, customers will talk a lot about wanting to put their turbine on a building or on the edge of a cliff. Here, you would think, oh, this would be the best place to put the turbine, but actually as that wind hits a vertical face of either a building or a cliff or a plateau or a mesa, it pushes up, and when you have vertical upflow of wind, that decreases the energy efficiency of the flow of the wind on the face of a horizontal axis turbine, which is what we have. This is a horizontal axis turbine, and so it'll decrease the efficiency. So really what you want to do is push that turbine back away from the face, so as that flow of wind comes up, it comes back down into a laminar flow, and it's able to utilize that laminar flow better. So now we're going to talk about this hybrid concept. So the hybrid concept, is really what a lot of the industry is moving towards, and I see more and more of this with all you guys, all the distributors and dealers and customers out there, is they want to combine wind and solar. It makes a lot of sense, and I want to kind of explain why it makes sense. So first of all, solar is great. We love solar. It's in the name of Northern Arizona Wind and Sun, and it's in the name of many organizations and so on, and it's great, but it does have a few drawbacks. Solar has low output during the winter months. It has diminished output at night and also during inclement weather. You guys know that, right? And you size your system because of that. But where you can benefit with wind is there are these 4 tenets that I'm going to talk about. I'm going to kind of run through this presentation and kind of prove these to you, that where solar has drawbacks, wind really takes up the slack, because the average wind speed is higher during the winter months. The air density is higher during the winter months, which means there's more power in the wind, which means there's more energy production. Wind on average is higher and stronger during bad weather, inclement weather conditions. And also wind frequently does blow more on those long, cold winter nights in a lot of places like North Dakota, Wyoming, South Dakota, West Texas, and so on. And so let's take a look at these 4 tenets right here of this presentation. First of all, hybrid systems are complementary, meaning that they help each other out. In the winter, when the sun is not so prevalent, you tend to have more wind. This is the complementary nature of wind and solar. It's like Mother Nature telling us to combine the two together, because the reality of it is, in the summer you have plenty of sun, and there's not a lot of wind. So the solar is doing all the heavy lifting in the summer months, but in the winter months, if you have a wind component added to your system, a small amount, then it's really going to help that battery bank during the winter months. So let's look a little bit at the wind resource map. This is for winter, and at Primus Wind Power, we really focus on winter wind resource, not so much summer wind resource or average wind speed, but winter wind speed, because that's really when you need the energy. And you can see, especially here on the northern latitudes as well as through the Midwest of the United States, you have a lot of good wind, because the darker the blue and the blue colors, that's where there's a strong wind resource. We're talking, 9.5, 10, 11 miles per hour or greater average wind speed in the winter, depending on how blue this is. Right throughout here, you can see this is the Rockies, and those are mountaintops. That's why you have these little islands of wind here. Along the coastline or along the Great Lakes, like up in here, great wind resource. Anywhere along the coastline. You can see Florida has no wind, right? But lots of wind or good wind along the coastline. Same thing with Texas, but in West Texas and in up here in northern and West Texas, you have good wind along the coastline as well. So something to keep in mind. So this is a wind resource tool that that's going to be coming out in April, so just next month, and I think it'll be really helpful. I'm going to be sending this out to all of our dealers and distributors, and I'm going to show you where this data comes from. But basically, you'll be able to this right here. You'll be able to pick one of 239 locations in the United States that are NREL sites. The National Renewable Energy Lab has been for 30 years has been looking at wind data, and they've compiled it. And we've created this. It's basically an Excel spreadsheet wind resource tool that you guys will be able to use. And I'm going to show you something you can use right now. But this will make it even easier for you to actually look at, okay, what is the average monthly wind speed? Remember, again, you want to look at winter speeds, right? So this is January through December. So right here, starting in January through December, and you can see, look, here in the January, February, March months, you can see you have quite a bit of wind, but in the summer, here's June, July, right? A whole lot less wind, and then it starts going back up again for November and December. That's the cyclic nature of wind. And then you can also give your customers information on how many kilowatt hours they're going to be able to produce from an Air 40 turbine. So this will be a great resource for you, and we're going to be rolling this out soon. But for now, you'll be able to use this resource, and I'm going to show you what this looks like. So this is, again, 239 sites, and I'm going to pull this over here to the screen. So this is 239 sites, and there's, anywhere from 4 or 5 to more sites depending on the state. But you can see Alabama has 4 sites, NREL sites. Here's Arizona has 4 sites, Flagstaff, Phoenix, Prescott, and Tucson. These are all NREL sites, meteorological sites, and so on. Arkansas, not very good wind in Arkansas, so not a lot of sites. Lots of good wind in Alaska. That's why they have all these different sites, right? And this is not only for wind data, but solar radiation data. But let's let's just look at like North Dakota. Okay, North Dakota, we are doing a lot of business with oil and gas. So I'm going to show you a site in North Dakota, and I'm going to show you how to look at this data. Here's Bismarck, Fargo, and Minot, North Dakota, right? So when you click on it, it gives you the longitude and latitude. It gives you, look, here's solar radiation, which also might be helpful to you. But it also gives you, if you scroll down, the average wind speed for the 12 months of the year. And again, here's January through December and the yearly average. So here in Minot, North Dakota, at this site, look again at the wind speed. So this is how you can determine whether your customer is a good candidate to add some wind into their hybrid system. Very, very simple to do. It'll take you all of 3 minutes to look this up. Ask them where they're closest to of one of those NREL sites. Then you can get a good idea of what the wind speed is in their area. Now it's gonna obviously fluctuate because they may be 50 or 100 or 150 miles from that site, but it'll give you an idea whether that area is good for wind or not. So here, January, 13.6 miles per hour. That's a strong average wind speed. Obviously, this is a great site. You can see here in the summer it drops down greatly. For June, July, and August, you see it's a whole lot less than in January, February, and look again here. It starts going back up again in November and December. But just a good resource for you to use when you're talking to your customers. Simply ask them, hey, where are you at? And let's find out what that wind resource is. I will send you this link. I'll send it to Ben, and Ben, if you could send it out to the other 4 guys, that would be the other 3 guys, that would be great to utilize. But it's just a very simple, quick and dirty way of determining whether your customer is a good candidate for wind. If they have a winter wind speed, and again, that's January, February, November, December, those months, if it's above about 9.5, 10 mile an hour average, I would say 10 mile an hour average, they are a good candidate for wind. If it's 11 mile an hour average, they're a really good candidate for wind. If it's like Minot, North Dakota, where they have a 12.5, 13 mile an hour average winter wind speed, they're an excellent candidate for wind. So you can, determine that with your customer. Canada, anybody, if you ever do anything up in Canada, Canada has tremendous wind resource. You can see here in the reds are all, and with the metric system, I recommend 4.5 meters per second or above would be the winter wind speed that you would recommend a turbine, an addition of wind into a solar system. Canada has a great resource as well. This is this Canadian Wind Energy Resource Map. If you work in Canada much, I can help you with this, but it actually gives you the winter wind speed on average here, and can really help you determining whether they're a good candidate. If you work in Europe at all, great wind resources as well. I can always help you with some of this information if you ever run into a European partner. Australia and New Zealand, the same deal. So let's talk about air density a little bit and the air temperature and how the air temperature with colder air increases the air density, which is what this is saying here. So as you decrease in Celsius, you're going to increase in air density, and basically what that means is during colder winter months, you're going to increase your energy production out of your wind turbine. You can improve anywhere from, depending on the temperature, anywhere from 5 to 20% increase just based on air density. Now, as you know, with solar, same kind of deal, right? When you have a really cold, sunny day, the voltage is going to increase in that on those solar panels, and you're going to be pushing a lot of high voltage into your battery banks. So similar in wind, the colder the day, the better it is. Well, if it's blowing for your wind turbine. So what I did was I looked at this same NREL data that I just showed you, and I took 30 years of data for Amarillo, Texas, Cheyenne, and Rapid City, South Dakota, and I said, you know what, is this old saying, when there's weather, there's wind, does that hold up? Is that actually true? And we did look at the data for many places, and I just pulled out 3 here, and it actually does hold true. When it's less sunny, it tends to be more windy on average. Not every day, but on average, you're going to get improvement, especially in a place like Rapid City, South Dakota. You have a 23% improvement of when it's less sunny, it tends to be more windy. That's what these charts show. You can see wind energy on the vertical axis and solar energy on the horizontal axis. And so over here, you have a lot of sunshine, a lot less over here. Over here, you have a less wind, more wind. So this curve goes up, so less sun, more wind. And that means you're going to have, on average, you're going to tend to have more wind when it's less sunny. So in inclement weather, it's always good to add that extra element, that wind element, into your hybrid system. Here's those complementary curves I was talking about before, but these are actually, again, NREL data, 3 different places in the United States. And you can see in the winter months, you have a lot more wind and a lot less solar, especially here in Fargo and in November and December. This one's really pronounced here, right? The complementary curve. January, February, you're kicking butt with wind, but not so much with solar. Same thing with November and December. It holds true with almost most places on this planet, except for maybe the Bahamas and the Caribbean and places closer to the equator. You tend to have a more stabilized wind-sun environment. So something to keep in mind. But here in the United States, it really holds true, that complementary nature of wind. You guys have all seen this before. This is a solar day, right? Blue is June, red is December. This is, again, NREL data, 30 years, Rapid City, South Dakota, what those days look like. Basically what we're seeing here is, which is, you guys, Ben and Robert, you know this, in December, that's why you decide your system for December 21st. In December, you're going to have a whole lot less sun. So you got to have more panels for December and January so that you can survive those winter months. But if you add wind into your system, you're going to survive those winter months a lot better, because on average, if you're in a decently windy place, you're going to have wind through those winter months, December, January. And so your system is going to survive a lot better. You're going to have less depth of discharge if you have that secondary component in there. Nighttime power production, this is Cheyenne, Wyoming. Again, look, all the way through the night and the day in Cheyenne, Wyoming, you're going to get wind speeds typically on average exceeding 13 miles per hour. So you're going to be pushing energy into that battery bank through those dark winter nights and days. to help your battery bank reduce that depth of discharge, help your customers out, increase the life of your battery bank. You've seen this before. This is a Trojan battery brochure with the different types of batteries, from gel to AGM to the flooded lead acid and so on. And you can see, based on the depth of discharge, which you guys all know, that the deeper you discharge that battery, the less cycle life you're going to get out of that battery. And I'm sure you size your systems for December 21st, 50% max depth of discharge. And so your solar panels and your battery bank are all sized for that. Well, if you add a wind component in there and you've done a little research and you know that that site where that customer is has a decent winter wind speed, you're going to push this depth of discharge to where it's less, it's not as deep, which means you're going to increase that cycle life of the battery bank, which means those batteries are going to last longer, you're going to save money for your customer, they're going to have to do less work lugging those batteries in and out, and so on. And so it's really going to help out that system by adding that one or two turbines into your system in the right wind resource, so that they can help during those winter months, during the storm periods, and so on. We like to say, solar is inexpensive, right? Less than $1 a watt for solar panels these days. But controllers, especially the new MPPT controllers, are not so inexpensive. So if you add an extra 100 or 200 watts of solar, which a lot of customers say, well, I'm having some trouble in December with my batteries keeping up. I really have to run my generator for a long period of time. I don't want to have to do that, so maybe I'll just add a few more panels. Well, the reality of it is that might work and it may not work, because if you have a 3 or 4 or 5 day storm or whatever, and then when you add those panels, it's not only the cost of the panels, but you might have to add an additional controller and so on. So that might be a case where you might say to the customer, look, why don't we add a wind turbine? So you seem to have a good wind resource. Here's your data. Let's put a air unit up there. There's a lot of options for towers. You can put it on the energy shed. You can do a very simple 27-foot guide tower kit. It has all internal integrated controls. You can retrofit it into the solar system, newer, existing, wires directly to the battery bank, so no controllers, and so on. So it's an easy thing to say and do for your customer if they're in a good wind resource. Just a little history about Primus Wind Power and Southwest Wind Power. So this is started with a 303, many years of improvement, all the way from 1995 to present. Where even today at Primus, we're tweaking the turbine, the blade set, the control algorithm, all kinds of things to make sure you have a robust turbine. Thousands of these units out there. By far the biggest, the turbine that's been sold the most over the years, the micro scale turbines, and it benefits from all these years of improvement. So it is really a pretty robust turbine today. When you're talking to your customer about which turbine to buy, if they're in a low to moderate wind regime, which is frankly most of the United States, you want to connect them with either an Air 40 and Air Breeze. The Breeze is the marinized version of the Air 40. If they're in a higher wind regime and there's no issue with sound, because these two turbines are by far the quietest, this turbine is the same as this one, except this one is marinized. These two turbines are essentially the same, and they're relatively quiet turbine due to the blade set. This turbine, the Air 30 and the Air X, again, same turbine. This one's marinized, has a different blade set. It spins at a higher RPMs, 1,800 RPMs versus 1,000 RPMs max for this turbine. So therefore, because of the blade set and a number of features, this turbine is louder. So if sound is an issue, keep that in mind when you're explaining that to your customers. But this is the higher wind speed turbine of choice. But if sound is an issue, you definitely want to talk to them about that. And then in some situations, very, very small percentage of the time, you can use the Air 30 and the Air X with a diversion, with a controller that has a secondary input, a wind input or a hydro input, and with a dump load, you'd open up that potentiometer, allow that turbine to run at a higher regulation set point, and when the TriStar says, my battery bank is full, it'll dump it into a dump load. Some customers go with this configuration. It's fairly uncommon, but if they want to dump load in their system and utilize that wind most efficiently, they can do that. Comparison, again, here are the MSRP prices. All of them have a 5-year warranty. Again, moderate sound versus very quiet. Keep that in mind. The blade sets, this is the 40 in the Breeze blade set, and this is the 30 in the X blade set. More surface area in the 40 in the Breeze blade set. That's why it can start up at 7 miles per hour versus this one starts up at 8. It does produce better, more energy in those lower wind speeds. The thing to keep in mind, as well as it's quieter. Any wind turbine worth its salt is going to have a power curve and an energy curve. If it doesn't, you got to be suspect about that turbine. Here's the power curve for the air unit. You can see this big spike right here is because at higher wind speeds, because of the higher RPMs, that 30 is going to outperform the 40. But in lower wind speeds from 7 miles per hour up to about 25 miles per hour, which is the majority of the time the wind is going to be blowing, the 40 is going to outperform the 30. If you have a site that is a high aggressive wind site, very robust wind site, mountaintop, industrial application like North Dakota, oil and gas, offshore platform, buoy platform, you know there's going to be high winds and there's no sound concerns, the Air 30 or their Air X is the way to go. If it's a residential application where it's around people, the Air 40 or the Air Breeze is the way to go, and it's going to produce more energy in those lower wind speeds. Again, here's the energy curve, and above average wind speed of about 13 miles per hour, and again, that's average yearly, which is not a lot of places. Above 13 or so, 13 and a half miles per hour, you probably want to go with the Air X or an Air 30 because it's going to do better in those higher average wind speeds. When you're talking about sound, customers have a lot of questions on sound. The Air Breeze is a really quiet turbine. All that you can see, the blue dot is the turbine operating, the green is the background noise. And as you move up through this scatter plot chart, it does blend in with the background noise until you get above about 25 miles per hour, and then you start to hear that turbine a little bit. So that's something to keep in mind, and you could show this to your customers. Let's look at some pictures, and then we'll be just about done. So this is how the Southwest Wind Power started many years ago. Now we've begun also. We do a lot of this off-grid cabin remote application work. This is a 45-foot guide tower, 8 guy wires and 2 different elevations on this 1.5 Schedule 40 1.9 OD pole that goes right into the yaw of the turbine. Very simple way to install, very inexpensive, but some folks, like I said before, don't like those guy wires, so that's why we're developing the monopole tower. But this is how it all started, just enough wind to power a few lights and maybe a small SureFlow water pump in this off-grid cabin. Worked great for many, many years, still does to this day, but these days they now incorporate solar because it's so inexpensive. Again, here it is. This is wind turbine. It blows 99% of the year in this location, the Himalayan steppes, and therefore, this is a great setup for wind, off-grid, remote location. Here's another application we see a lot of, typically on the stern of a sailboat, either in 1 or 2 turbine application. This is an Air Breeze. On the stern of this sailboat, we sell this mast and stay. Here's the mast, 1.5 Schedule 40 pipe. Stay kit right here. This is stainless steel, a little different than our land kits, but this is a typical sailing application. Again, off the stern of the boat, this is a trimaran, right off the stern of the trimaran. And also customers will put them off the mizzen mast right here. This is a little turbine off the mizzen mast of the boat. Just a different way to do it. 90% of the time we see them right off the stern, a little more accessible, a little easier with a mast and stay kit. Here's a common application as well, off the stern of the boat, 2 turbines with solar. This is a cruiser. They live on their boat, so they have to have the solar and the wind together. Parking lot applications are also a big part of our business, where we see the parking lot light with solar and wind combined, especially for places that have difficult winters, and the solar can be down for 3, 4, 5 days. This is oil and gas. Again, look at these towers. These are very short towers. This is 27-foot tower kit, 4 guy wires. This is less than 20 feet here. Because these are typically in places like eastern plains of Colorado, West Texas, North Dakota, where there's minimal surface roughness. You can see here no trees anywhere around. They don't need to go up very high. Just cost more money. And really what they're looking for is those winter wind speeds when the solar is not doing its thing. This is solar energy skids, solar wind energy skids, hybrid skids. Down here is the battery bank. They have the controller in here, 500 watts of solar, and this is a lattice tower connected at 3 points to this 4x4 skid, pallet skid, essentially metal, and then going up to the stub pole that extends up to the Air 30 wind turbine, and this is a really common application we see with oil and gas. They drop these at sites where they need remote power. They work great, and so they just haul them on. They can put their fork skids right in there, and they're standalone systems. Plug right in. This is Antarctica. You can see, reason why I want to point this one out is because of the different elevations of the turbines. So anytime you have a turbine right behind the next turbine, you want to have it at a different elevation so you don't have that downwind shadowing effect of the upstream turbine to the downstream turbine. So just something to keep in mind when you're working with a customer who needs multiple turbines on an installation. You want to be cognizant of that downwind shadowing effect and have the turbines at different elevations. Again, here, turbines at different elevations. You can see solar. These are Air X Marines, great application for offshore buoy platforms and so on. Again, 2 turbines, 2 solar panels, works great throughout all conditions. Telecom is a big application for us as well. Railroad, we work a lot with BNSF for off-grid applications. Also here is some folks will put these turbines on their RVs. This particular person used a mast and stay kit on their RV with their solar. Lots of good wind here right off the water, no surface roughness and so on. Alaska here, you can see this solar panel is hurting, got all kinds of snow and ice on it, but the wind turbine is really cranking away and doing its thing, powering up that directly wired, look at the wire, directly into the battery bank right there. So very simple application, but works great in places where you have winter wind speeds that are fairly good. So hopefully you'll start talking to your customers a little bit about combining wind and solar together, and I really appreciate you guys listening and to my presentation and taking the time and thinking about this hybrid concept. So, thank you very much for being a part of this Primus Wind Power webinar regarding the off-grid system and the hybrid solution. My contact information is right here on the screen, as well as all of our tech support number for Bo Colton in the tech support department, and he's happy to help you as well as I with any questions you might have. So just really quickly about Primus Wind Power, we're a division of Primus Metals, which is a precision metal manufacturing company out of Denver, Colorado. So all of our turbines are manufactured here in the USA, in Denver, in our large factory there, which is combined with the Primus Metals factory. We have engineers there and so on. So we're always improving and making our product more robust. The company mission is very similar to what we've had for many years, is that we want to be the largest developer of small-scale wind turbines. We call them micro turbines, with providing a high degree of robust or reliability. We want the turbine to be robust, and we also know that it has to have value. It has to be inexpensive, or it's challenging to compete with the very low prices of solar these days. So that's our mission. Few updates from the industry. Basically, Primus acquired the Air product line from Southwest Wind Power in January of last year, and we've been producing it and manufacturing it ever since, for a little over a year now. And so some of the things we've done since the acquisition was we've added the Air X Marine, which was discontinued in 2012, I believe, by Southwest Wind Power. We've added it back into the portfolio for marine industrial applications. It's a great turbine for that application. We've also are in development and almost completed on a monopole tower design. So this is a tower without guy wires. It's affordable and UPS shippable along with the turbine and the foundation. And so it'll come with a foundation that has stamp drawings and so on, dry stamp drawings, so that the customer can be able to put this turbine up on a 10-meter tower, so it'll be about 10 meters in height, and it doesn't have the guy wire. So we're excited about that. That's something that's been out there for a long time that we've been wanting to bring to fruition. We're NREL testing. We're testing at the National Renewable Energy Lab in Colorado for this concept, this hybrid concept, seeing how solar and wind interact. So we'll be talking more about that in the future, and we're also seeing the expansion of this oil and gas market for SCADA platforms, which is a communication platform. So they've used solar in the oil and gas markets for a long time, but now we see them combining solar and wind together because for them, it makes a lot of sense because these systems have to be up 24/7, 365, and they have to have on-time performance, and that's what wind and solar combined do. They allow that. Whisper line, the Whisper 100, 200, 500 wind turbine, which was a off-grid wind turbine as well, was sold to a company in India called Luminous Renewable Energy. They are in the United States under the distributor name of John McDonald Solar and Wind, also out of Colorado. So if you need information or your customers have questions about the Whisper, I can give you their contact information. The SkyStream line was sold to a company in Oregon called Exeris. That's the SkyStream 3.7 grid tie turbine. So if you ever have customers interested in that product and need information, I'm happy to help. As far as we know, Southwest Wind Power discontinued all operations as of March of last year. Let's talk a little bit about the turbine itself and the parts and pieces. Starting on the left with the front of the turbine, the nose cone is not just there for aerodynamic purposes to help flow that wind, that laminar flow of wind over the blade set and the hub, but it also helps to prevent water infiltration through the bearings and the hub itself. So it's important to have a hub affixed have the nose cone affixed to the hub of the turbine. To mitigate some of those issues. It is a 3-bladed turbine, 46-inch rotor diameter. All of our turbines, all models of our turbine have the same rotor diameter, 46-inch, except the blade set is a little different in terms of the surface area between the Air X and the Air 30 and the Air Breeze and the Air 40. And I'll explain that a little bit more. As you move through the turbine, here's the face, the stator isolator pad, and here's the stator itself with the windings and so on. And then right here, the brains of the turbine essentially is the circuit card and the internal rectifier with the potentiometer attached to it, which is right here. We'll talk about that in a second. But the circuit card is the control algorithm of the turbine. It's the brains of the turbine. It tells it when to start, when to stop, when to start exporting energy to the battery bank, what RPMs to hold the turbine at, when to turn the turbine off when the battery bank is full, and all those things in there. As well as in there is a rectifier, because through the stator right here, the turbine actually produces what we call in the wind industry wild AC, which is essentially unregulated AC energy, and it goes through here, the circuit card, and it goes through the rectifier, and the rectifier rectifies that wild AC to 1224 or 48 volt DC, which then flows down tower to the battery bank. This part of the turbine here, or any wind turbine, is called the nacelle. That's the body of the turbine. And then you have here the inner outer bearings, the yaw assembly, which includes the brushes and the slip rings. and this is the part that connects to the tower, and the tower connection is a 1.5 Schedule 40 or Schedule 80 pipe, steel pipe, which has got a 1.9 OD, and that's the typical tower of the turbine. Again, 3 wires down the battery bank, including the ground. Very simple. All the turbine operations are done up tower. So this is called an up tower turbine. Specifically, it's an upwind up tower turbine because the blade set faces upwind, so the direction of the wind is this way on the blade set, and the turbine is up tower controls. There are turbines out there that have all their controllers down tower, but our turbine has up tower controls. Here's what you get when you get a turbine in from the factory. When you purchase one, 3 blades. They're balanced blades, so if you have an issue with the blade or your customer has an issue with the blade, they do need to buy an entire new blade set with new hardware because they are balanced. If you put another blade on this blade set, one blade could be out of balance and really cause problems, obviously, for the turbine. So they are balanced together. This is a land unit. It is aluminum in color. You know, aluminum. It's not painted. It's just standard aluminum. Whereas the marine versions are all painted with a special paint, corrosion-resistant marine paint. The nose cone are all gray for the land versions, whereas they're white for the marine versions. This is the hub. There's 2 hubs. The hub for the Air 40 and the Air Breeze looks like this. It's got 1 hole in it, and the root of the blade goes in the hub only one way. We call it a smart hub because it's very easy to put the blade on the hub and not mess it up in terms of put it in the wrong direction. And it's got only 1 hole, whereas the Air 30 and the Air X hub, the way to tell the difference is by that hub, and that has 2 holes, and it's a little flatter. So that's really a common misconception or a common question with when we're talking to customers about the differences in the air units. That's a way to tell the differences between the units. Here is the blade and hub assembly process. It's very simple. It takes less than 10 minutes. It's attaching the blade root to the hub, and then screwing that down with the Allen key, attaching it to the turbine body itself, and then the jam nut goes over that, and then the nose cone pops over the hub. Very, very simple process. With every marine turbine that we sell, so that's the Air Breeze and the Air X, that you get a stop switch. And the reason why you have a stop switch with every marine turbine is for 2 main reasons, but there's also a number of other reasons. But for storm conditions, when you're on a sailboat and you see a squall or a storm coming in, and you want to turn that turbine off for a whole number of reasons, you can do so very simply by hitting the stop switch here, and it directly shorts the windings, which is what you really want to do to stop that turbine. And another reason is because any rotating mechanical device, such as a wind turbine, mounted to the hull of a boat, or a building for that matter, is going to produce some vibration. And that vibration is going to be translated down tower through the tower into the building. And so some folks who are sleeping on the boat, and maybe it's a really high wind speed, and that turbine is spinning like crazy, it could translate some vibration into the hull, and they might have an issue with it through the night, so they would hit the stop switch and then turn the turbine back off in the morning. So those are 2 reasons why it's a good thing to have on a marine application, but I also recommend a stop switch. So when you're talking to your customers, I would recommend a stop switch for a land application as well. And for the reason why is because we're talking about often off-grid cabins, where if it's a hunting cabin, they can be away from that cabin for several months at a time. It's a good idea to directly short the windings through the stop switch. If that turbine is not going to be charging the batteries, or especially if you have solar with it and it's going to be in regulation mode, meaning it shows the battery is full and the turbine is in regulation, you want to hit the stop switch if you're going to be away from that cabin for a long period of time. If there's a storm coming in when you know there's going to be 70, 80, 90 mile an hour winds, that turbine's going to be in overspeed protection anyway. It's better to throw that stop switch and directly short the windings. You don't have to, because it'll go into overspeed protection and stop itself, but it's just a good thing to do if you're there at the location. So those are just a couple reasons why it's good to have a stop switch in line. This stop switch is a single pole 3-position DC rated stop switch. We call it a break before make stop switch because it actually severs the connection from the turbine to the battery bank as you're going from run to stop. And that's why you need this specific stop switch for our turbine. Just something to keep in mind. Another 2 things we recommend when you're talking to your customers about installing a wind turbine is adding a amp meter, and this is an analog amp meter, so there's no parasitic draw, there's no milliamps coming out of that battery bank because of the draw of the amp meter. It's very simple to wire and very inexpensive, but it's a good little troubleshooting tool as well as something for your customers. If it's really blowing, they can see how many amps they're pushing into their battery bank, as well as really highly recommend anytime you're connecting a turbine to a battery bank, you go through a fuse or a breaker. This is the breaker we sell, very inexpensive. It's a $25 part. It's got a little pop out here that you can reset, but very, very simple breaker, but just a good thing to have in line between your turbine and your battery bank. The potentiometer is something you guys need to be aware of. It's on the side of the turbine. I'm going to show you where it's at. So if we're looking at the turbine here, this right here on the side is there's a screw. That's called the potentiometer screw. I'm going to talk about that just in a second. But while I'm here, I also want to talk about this right down here. There's a little LED light on the bottom underneath the nacelle. So as you're looking straight up, you'll see it on the bottom of the turbine. It's fairly bright, so you can see it during the day as well as at night. But this is something good to know when you're talking to your customers, especially if there's any troubleshooting questions. Obviously, we can take those questions, but it's good for you to know as well. So if this if this LED light is lit, if it's solid, you'll see it's solid. If it's solid, that means the turbine is spinning, it's producing energy, and exporting that energy to the battery bank. So it's working and pushing electrons into your battery bank. If this LED light right here on the bottom of the turbine is blinking slowly, that means it's in regulation. Regulation means it's stopped sending energy to the battery bank. It's shorted the windings through the circuit card. The blades will still be spinning, but very, very slowly, because it's a short to the electronic short to the windings. So it's not like a mechanical brake. It's a electromagnetic brake. So it still might, in high winds, it still might spin those blades slowly, but it's not exporting energy to the battery bank. So that's blinking. If it's blinking very rapidly, like 5 or 6 times a second, that means it's in overspeed protection, which happens at about somewhere between 50 and 60 miles per hour, depending on the gusts and all kinds of things. If it's blinking very rapidly, it's shorted the windings again through the circuit card, and it's told the turbine to stop sending energy and go into overspeed protection, short the windings, slow down that blade set. So just something to keep in mind when you're talking to your customers. So the potentiometer is what you use to, what the potentiometer does. It adjusts the regulation voltage set point. And so here's what the factory settings are for the different 12, 24, or 48 volt systems. But you can set it for anywhere in these ranges. Normally, I'd say 85% of our customers don't touch the potentiometer. But our marine customers often do, as well as customers who have a specific, maybe a sealed battery bank that's a specific, usually a pretty expensive battery bank, typically not with a flooded lead acid battery bank, but even these lithium-ion battery banks and so on, you can adjust that voltage regulation set point to the voltage that is best for the battery bank. And so to do that, you take that screw and you turn it 1/8 of a turn clockwise to turn it up voltage, 1/8 of a turn counterclockwise to turn it down, and here's how much it changes based on the eighth of a turn. And so you can adjust that voltage regulation set point. We don't recommend you do that unless you're comfortable and you know what you're doing, because you can fry your battery banks. You can overcharge your battery banks, damage your battery bank if you don't do it correctly based on what your battery, the specifications of your battery. Something that customers we do hear often is that, hey, I'm going to turn this voltage regulation set point, I'm going to turn that potentiometer all the way up, and I'm going to crank out the amps out of my turbine. Well, that's not what it does. It's not going to increase the power output of the turbine. It will not do that. What it's going to do, it just adjusts the point. It adjusts the point at which the turbine stops charging the batteries. Okay, so there's a big difference there. And so customers can really make a mistake by setting that voltage too high. They can potentially burn up their battery bank. They can overcharge the battery bank and damage them. So just something to keep in mind. It is there for the customers who do need to change it for those reasons that we just talked about. Specs of the turbine here, it only weighs 13 pounds. It has about a 1 meter rotor diameter, 46 inches. It's a very lightweight turbine. It has about a 1 meter swept area. You can see the different energy production here for the different turbines. The blades are an injection molded composite of fiberglass and plastic and all kinds of other materials. It is a permanent magnet brushless alternator. Again, alternator, wild AC, right? We talked about that. And the mounting is a 1.5 generally a Schedule 40 pipe, 1.9 OD. All of our turbines have a 5-year warranty. And our customer support and technical support is right here in Flagstaff, Arizona, and very, very helpful. Talk a little bit about tower height when it comes to wind turbines, because this is a controversial issue with micro wind turbines. Really, we don't see towers above about 45 feet. In fact, the best-selling tower that we have is a 10-meter tower. It's actually the 27-foot guide tower. Because it's inexpensive, it gets you about 30 feet up in the air, and it's relatively short wire run, and so on. So, but if you want to, you can put that turbine up higher. The higher you go, the better laminar flow of wind you get, of course. But does it make sense for the customer? Is the question you got to ask. More, a bigger foundation potentially, or more guy wires, more pipe. Increasing the wire size potentially from a number 8 to a number 6, or a number 6 to a number 4. So all these things increase the cost of the installation. To get a little extra energy, a few extra amps or kilowatt hours out of that turbine per month, does it make sense? And in most cases, our dealers and distributors and customers say no. The predominant size tower is about 10 meters. That's about where they're putting these turbines at. We don't sell a lot of 45 tower kits, to be honest with you. Most of our tower kits we sell are 27, or customers will buy a roof mount kit. Again, when you put that roof mount kit on the side of your non-inhabited energy shed, or your shed or your barn, it is going to reduce the efficiency of the turbine because of the turbulence of the vertical face of the building and the roof line, but it's a very easy place to install a wind turbine. And sometimes that's what really matters for the customer. So just something to keep in mind. Siting a wind turbine is important. Again, we do sell a roof mount kit that goes up through basically the side of the building, up through the soffit, and usually about 6 or 7 feet above the roof approximately. It's a great way to install. It's very simple, very easy, but again, you're going to lose some efficiency because of the fact that there is more turbulence up there. But if it's high winter wind conditions and you have a lot of wind as it is, it may not matter. So something to keep in mind. But when you are siting a turbine, these are things to keep in mind. Flagging, this is what this is called, flagging. You can see where the trees are bent down in the prevailing wind direction, or you see brush up against the fence line. We see that a lot here in Arizona, especially out towards Doney Park and Timberline area and on the Navajo Res. But when you're siting, the most important thing is just to put that turbine in the prevailing wind direction. of the building, and so on. And if you put it in the prevailing wind direction, you're going to get your best chance to get the most energy production out of that turbine that's possible. If you have a customer that says that they're on the water, like a lake or a sea or an ocean or whatever, that's great because over water you have very minimal surface roughness, we call it, and so you're going to have these good laminar flow of winds. You can see right here, this laminar flow of wind, these lines are parallel, and that means good non-turbulent wind, so great energy production out of that. If you're up on a hilltop, like this particular application, because as the wind flows up the hilltop, you have minimal surface roughness again, you're going to see that wind start to compress, and as it compresses, it increases velocity, and therefore you're going to tend to have a higher wind speed on a hilltop. Now on like a building with a vertical face or a plateau or a mesa or a cliff, that wind's going to hit that vertical face and get pushed up, and it's going to break up that laminar flow. You can see this turbulent condition right here. So instead of putting this turbine right here on the edge of the cliff where, you know, some folks would say, oh, that makes sense, let's put the turbine right on the edge of the cliff right here. It's actually better and more efficient for that turbine to be placed away from the cliff so that that laminar flow can come back down and hit that blade set with a good laminar flow, horizontal flow of wind. So just things to keep in mind when you're talking to your customers about potentially siting that turbine. So now we're going to talk about the hybrid concept that really a lot of folks are moving towards these days. The hybrid concept is really combining wind and solar together, and typically what I recommend is if it's a really good wind resource, you might want to have 20 or 30% of the power coming from wind and 70 to 80% of it coming from solar. If it's an average to moderate wind resource, you might want to only have 10% wind and 90% solar, but you want to have some kind of a wind component in there, an additional charging component. And here's the reason why. Because we at Primus, we love solar. I have solar in my house. Bo has solar in his house. Solar is awesome, but it does have a few drawbacks. Here are the 3 drawbacks we see. Solar has low output during the winter months, December 21st, the shortest day of the year. That's why you size your systems for typically December 21st. You have a lot less sun than you have on June 21st. So something to consider. Solar has diminished output during bad weather conditions. So when you have a weather system rolling in, you have those clouds, you have diminished output, but you typically have wind. And solar has no output at night. So on those long winter nights, you have no electrons flowing into that battery bank. It's good to have a secondary source. So on the wind side, we see that the reason why it's important to have a hybrid system and why your customers would benefit from this is these 4 main tenets right here that I'm going to outline, these 4 main tenets. I'm actually going to show you some slides to try to prove these 4 tenets to you. The average wind speed is higher during the winter months. We know that intuitively, but that's actually through data, that's the case. We do have higher wind speeds in the winter months, not a whole lot of wind in the summer. Air density is higher during the winter months because it's colder generally, and if you have higher air density, you have more power in the wind, therefore more potential for energy. Wind on average is stronger during these bad weather conditions. So when you have bad weather moving in, you're going to have wind moving in with that, which is going to help your battery bank. And wind does blow more frequently on those long winter nights, especially in places like North Dakota, South Dakota, Minnesota, Montana, Wyoming, etc. You're going to have those winter nights where you don't have no sun, but the wind is blowing, the wind is howling, and you could be producing energy from that. This is kind of a slide that resonates with a lot of our dealers and distributors and customers, is this complementary nature of wind. It's like Mother Nature telling us that it's probably a good idea, depending on the wind resource, to combine the 2. So here we are in the winter months. You have lots of wind, not as much solar, especially during storm periods. But in the summer months, lots of sun, but not a lot of wind. So combining them together is a good idea. The complementary nature of wind and solar. Here's the winter resource map for the United States, and at Primus Wind Power, because of this concept of the hybrid solution, we always combine wind and solar together. Excuse me, whenever we're recommending wind, we always recommend it with solar. We concentrate on winter winds. We don't talk about average wind speeds because the average wind speed doesn't matter. It's really what matters is the winter wind speed. So here for this chart, you can see the darker blue, the higher the wind speed. Anywhere it's blue, you're going to have high average wind speeds for winter. But you can see all throughout here, the Midwest, up here in the northern latitudes, around the Great Lakes, up here in the Northeast, North Dakota, South Dakota, Montana, Wyoming, etc. All these places have really good wind. Mountaintops here in the Rockies and Arizona right here, right? You have high wind speeds along the coastline, are good wind conditions because that long fetch of zero surface roughness over the water. You can see Florida has terrible wind unless you're on the coastline where you have some decent wind. So just, again, winter wind speeds, a lot, especially here in the Midwest, a lot of the places throughout the United States in the winter, there's a lot of places that have really decent wind. West Texas, here along the coastline as well. A lot of Texas, except for this part right here, has good wind speeds. That's why we have a lot of installations in Texas. We have a lot of installations in Montana, Wyoming, North Dakota, South Dakota, and so on. So something to keep in mind. This is a tool that will be you'll have access to here in April. It's a tool that where you can look at any of the 239 NREL locations across the United States, and this will be a drop-down menu that gives you the location in alphabetical order, and you'll just ask your customer, okay, where are you located? And then you'll ask them what NREL station are you closest to, and then you'll be able to pull up the monthly wind speed. And again, you'll look at winter wind speed only. So here is January through December. In this particular example, here's January through December, and you'll focus on November, December, January, and February. That's when they really need the extra energy, right? And so you'll focus on those months, and you'll see, look, well, in this particular location in South Bend, Indiana, in January and February, you had 11 mile an hour or greater average wind speeds for both November, December, January, and February. So in this particular location, probably because you're above about a 10 mile per hour wind speed, 10.5 mile per hour wind speed, this is probably a good candidate to have a wind turbine in this particular location. Also, this is the power curve, how much kilowatt hours are going to be generated for the Air 40 over the month period, January through December. So you have a curve that's telling you, look, not a whole lot of energy production in the summer, but you're doing pretty darn good in the winter months. So this will be a tool available to you. But right now, for now, we have this tool, and I sent this URL. Sorry, it's hard to see, but I sent that URL to Ben, and he should have sent or will be sending that to you in your email. But I want to show you what this does, and this is a tool, again, for 239 NREL locations throughout the U.S. This is 10-meter data, so this is about where the turbine's going to be in hub height, and it's pretty cool. Let me show it to you. So this is, again, NREL data, 10-meter data for 239 locations throughout the United States, and it's in alphabetical order. Each state has anywhere from 4 to 15 or 20 locations. You can see that Alabama doesn't have a lot because not a lot of great wind in Alabama. Alaska has a lot of locations. Arizona has 4. But each state, Arkansas only has 2. Not a great state for wind is Arkansas. But all these different states have different locations that you can look at and say to your customer, well, where are you located? Let's take a look at the NREL data for your particular location. I want to look at one state with you. Let's look at North Dakota. Let's look at Minot, North Dakota. Okay, we do sell quite a few into Minot, North Dakota. A lot of off-grid there, as well as oil and gas. And so, nice thing about this is you have not only the wind data, longitude, latitude, and so on, but you also have the solar radiation data, which might be helpful to you guys. So you can look at that for the 12 months of the year. So you have all that data. And again, this is 30 years of data, 1961 to 1990. So 30 years of data. So quite a bit of data here. But what I really want to point out to you here is the wind speed. So down here, if you go to average climatic conditions, and you have, again, January through December, here is the wind speed data in miles per hour for this location. Again, remember our cutoff, it's about 10 and a half miles per hour is where you start recommending wind at a particular site. That would be about 4.5 or so meters per second of wind. But here in January and February, look at the wind speeds here, well above that cutoff. November, December, same thing. Again, this is Minot, North Dakota. Now, if you look at June and July and August, you can see the wind starts to die down a little bit, average wind speeds throughout the month. So very simple to do. Takes you, a couple minutes to when you're talking to a customer, ask them where they live. If they're putting in a system, have you ever considered wind? Well, let's look at your wind resource, and then you say what station, what NREL station are you closest to, and you can provide this information for them. You are educated and informed, and that would be very helpful to them to let them know if they're a good candidate for wind or not. And in a lot of cases, you can find out that they may not be, but in a lot of cases, they will be. So great resource. Keep this one in mind as you're talking to your customers. This is the Canadian Wind Resource Map. It's also a great resource if you have customers up in Canada. Lots of places in Canada have great winter wind speeds, especially along the Great Lakes. This is what the resource map does. You click on a location here. This is, again, the Canadian Wind Resource Energy Map. The URL is right here. This webinar is on our site, on the Primus Wind Power site, so you can access this. You can also Google Canadian Wind Energy Resource Map. But you click on a section of Canada, it comes up on a map, then you click anywhere on that map, and it'll show you the wind resource data that looks like this. And again, you focus on winter. It gives you annual winter, spring, summer, and fall, which is nice. I'll give you the wind rows, which tell you where the predominant power in the wind is coming from. All kinds of great information here. It's in meters per second, so you just to get to miles per hour, it's a calculation is 2.2. So keep that in mind. So very helpful resource here if you have Canadian customers. Western Europe and Northern Europe also some great wind resources. New Zealand, a little bit better than Australia. Most of Australia, unless you're on the southern coastline, you can see not a lot of great wind. Interior of Australia is not great wind at all. So something to keep in mind when you're talking to customers. We talked about air density. This is just very, very simple. Tells you that as the temperature of air decreases, so your air temperature decreases, your air density increases. And so just like with solar, if you have a really cold day, that voltage on your solar is going to go up. Just as in wind, you're going to have more energy production, anywhere from 5 to 20%, depending on how cold it is, of energy production out of our wind turbine, depending on the air temperature. So again, winter wind speeds, winter air density, all makes a big difference when you're talking about energy production in that battery bank. Here's the winter wind during inclement weather charts. So I picked, again, 30 years of data, 3 different sites, and what I wanted to prove here was when it's less sunny, is it in fact more windy? Does that old saying, when there's weather, there's wind, does that actually hold true? And in actuality, it does. By looking at the data, these are just 3 of the NREL sites. The horizontal axis is the solar energy. So as you go across this, you have it's more sunny, and this is the vertical axis is the wind energy. So as you go up, it's more windy, and you can see as it becomes less sunny, it tends to become more windy. That's this curve going up, or this line going up. It's depending on the location, like here in Rapid City, South Dakota, it's much steeper, but just proving that it does, on average, when it's less sunny, it does tend to be more windy. Here's complementary curves for, again, using NREL data for 3 different places on the planet, in the United States anyway, Fargo, Billings, and Minneapolis. And you can see that complementary nature of wind really holds true. Here in the middle, in the summer months, not a lot of wind, quite a bit of solar, especially here in Billings, Montana. But the opposite is true in the winter. Lots of wind, but not a lot of solar. Something to keep in mind when you're talking to your customers. You guys have probably all seen this, the solar day. So again, this is the average solar day for June and December for 30 years here in Rapid City, South Dakota. Quite a distinct difference. Look at the amount of time during the day in June that you have solar radiation hours versus in December. Quite a distinct difference. So not a whole lot of time in December to really push electrons into that battery bank. That's why it's important that you have that secondary charging source. If you add on a winter storm in here that pushes that battery bank down even farther, if you've got only solar, it really makes sense to have wind. Same thing with nighttime here in Cheyenne, Wyoming, winter months, 1990. Again, you're going to be above 13 miles per hour pretty much throughout the whole day. Again, this is going to be all over the place because it's wind, but pretty much throughout the entire month, you're going to have wind conditions that you're going to be pushing energy into that battery bank in the winter. You've all seen this before, I'm sure. This is a Trojan brochure of different types of batteries, anywhere from AGMs to gels to flooded lead acid and so on, and the depth of discharge for those different types of batteries. I know that most people size their systems for maximum of 50% depth of discharge for December 21st. So basically what we're saying here, by adding wind, you could push that depth of discharge up to lower levels. You could be in the 20 or 30% or 40% depth of discharge if you have an auxiliary charging component in that system. So what that's going to do for you and your customer primarily is it's going to allow that customer for that battery bank to potentially be maybe a little bit smaller, to add a few less solar panels, and that battery bank potentially is going to last longer because you have those electrons flowing into it during the storm periods in the winter, or during December and January when you have a lot less sun. So it pushes you up on this scale, this cycle life chart, to allow you to have an extra 200 or 300 or 500 cycles out of that battery bank so that that battery bank will last longer. So, solar is inexpensive. We all know that. It's very simple. A lot of customers will say, well, let's just add an extra couple solar panels and maybe I'll get myself through the winter months better. I'll have to use my generator a little bit less. And that's true. You can do that. It's relatively inexpensive to do that. But if you have to add a charge controller, especially an PPT charge controller, it can get expensive. And so what we recommend really is the best solution, if you are in a good wind resource, is to add an auxiliary charging component, a wind turbine, into the system. And especially if it's an inexpensive turbine, you can add it directly into a system, either an existing system or a new system. It could be wired directly in the battery bank because of all the up-tower controls. Very, very simple and relatively inexpensive to do that. It still might be slightly more than the cost of adding solar, but again, you have those two charging sources for when you have a storm period or in the winter months when you don't have as much solar. So just a little reminder that this air turbine's been around for a long time. Started in 1995 with the 303, the 403, and then the X, and so on. And it's just lots of units out there, over 150,000. Great support from us at Primus. Lots of tweaks and changes to the turbines over the years to make it more robust, more reliable, quieter, etc. So it's not a Johnny-come-lately turbine. It's not a Chinese model that you're concerned about the support, and it's only been around for a little while. So just something that's also a nice, when you're thinking about wind, you want to have a turbine that's been out there for a long time, like a Berge or like an air unit, because we've been around for a long time. So just remember, when you're talking to your customers about which turbine to pick, there are a variety of these turbines. There are actually 4 different flavors in the 3 voltages, 12, 24, and 48. And so most applications are going to be either the Air Breeze or the Air 40. These are the same turbines, except for the Breeze has the painted coat on it, the marine coat on it. The Air X and the Air 30, these are the same turbines, except for this one's got that painting on there, that coated on there. But in a low to moderate wind regime, this is the turbines of choice. For higher wind regimes, you want to go with the Air 30, the Air X, as well as industrial applications. So any oil and gas, offshore application, a marine buoy application, scientific instrument application, any of those type of applications where it's not really going to be around people, telecom application, railroad application, that's where you'd go with the 30 or the X. If you want a quiet turbine where it's going to be around people, the 40 and the Breeze is the way to go. If you have a really high wind speed application, this might be a good way to go. This is a very limited amount of our applications. We don't see this very often, but you can hook up a TriStar 45, which has that auxiliary input, has the wind input, and a dump load, a diversion load to it. And what that does is you open up the potentiometer, and when the TriStar sees high battery voltage, instead of shutting the turbine down, it actually starts to dump the energy into either a resistive dump load like a air heater or a water heater. So really a good way to go. It does make the system more expensive by adding these components, but it's a way to get all the usable energy out of the wind, especially if you're in a high wind speed area. We do see this application, and it can make sense. Comparison chart, here's the MSRPs on the turbines, the land versus the marine. All of them have a 5-year warranty, and there is a sound difference between the turbines. The reason for the sound difference between the Air 40 and the Air 30 is really twofold. Number one, with the 40 and the Breeze, you have a wider blade set. It's a little stiffer. It spins at a lower RPMs, which helps to control the sound output. The 30 is a thinner blade set. It spins at a higher RPMs, about 1,800 RPMs. It has a feature in it called aeroelastic stall, which allows the blade tip to flutter as it gets up into those higher RPMs, and that produces quite a bit of sound. So keep that in mind when you're talking to your customers. Any turbine worth their salt is going to have a power curve and an energy curve. This is the power curve for the 4 turbines we have, the Air 30 and the Air X and the Air 40 and the Air Breeze. You can see this big spike right here is because this is that 1,800 RPMs at high wind speeds. It can produce over 400 watts, whereas the Air Breeze and the Air 40 is pushing 250 watts. Really, most of the time it's at 200 watts max. So something to keep in mind. But the reality of it is that 40 and the Air Breeze is going to outperform the 30 and the Air X at the lower wind speeds, which is the majority of the time you see wind, and that's below 25 miles per hour. So keep that in mind when you're talking to your customers. Here's the energy curve. So this one was instantaneous power at any given time in watts. So this one is kilowatt hours in a month. And so that's why the 30 is called the 30, because Air 30 in a 12 mile an hour wind speed will produce 30 kilowatt hours a month approximately, and the Air 40 in a 12 mile an hour wind speed will produce 40 kilowatt hours a month. Remember I said the Air 40 is going to outproduce the Air 30 and the Air X at those lower wind speeds because of the more surface area on the blade set, and also the control algorithm is optimized for those lower wind speeds. So that's why you get these dotted lines right here as you get up into higher average wind speeds. So this is an average wind speed here. So if you're in a 13 and a half, 14 mile an hour wind speed, average for a location, that's a very, very high wind speed. In that location, you would never want to put an Air 40 in there. It would be an Air 30 or an Air X. Here's the sound data for the Air 40 and the Air Breeze. Again, remember those are the same turbines, except for the Breeze is marinized. And the blue is the turbine in operation, and the green is the background noise, and a maximum of 65 decibels on this one. You can see the blue and the green kind of all blend in together as you're going up with this decibel chart, and the wind speed increases. Not until you get above about 25 miles per hour do you start to actually hear the turbine, the blade set of the turbine. Anything below that, the turbine will just blend right into the background noise. So it is a very quiet turbine. Let's look at some pictures. This is kind of how it all started. with the air units back in 1995 for off-grid cabins, just to power a few lights, maybe a well pump, a water pump for water and lights in the cabin. This is a 45-foot guide tower, 8 guy wires, schedule 40, 1.5-inch pipe. This off-grid cabin application. We still see a lot of this today. Here's another application, again, very remote, right? The Mogollon Steppes here, very simple application, no solar at all really in this application, just a wind turbine on a 27-foot tower, powering some lights. This tower they can take down and move with them if they want to. It's very, very simple. That's an Air X from back in the late 1990s. Still see a lot of this today. We still see a lot of these applications. Another application we have is marine. This is a mast and stay. You can see the stay here, the metal stay and the mast. This is an air breeze on this sailboat. Very great application for sailboats because there's not a lot of real estate on the deck of a boat, and so they love to put wind turbines on boats. Again, here are more boats, different applications, different ways they are mounted. This is a trimaran mounted on the back of this boat, as well as they can mount them on the mizzen mast here of the boat. Multiple turbine application with solar on this particular one. So again, here's 2 turbines with the solar panels. Parking lot light applications, we often see this. This is oil and gas. Very short towers, again, because you have very little surface roughness here, but always combined with solar, hybrid solutions. They love these things in North Dakota, West Texas, Pennsylvania, New York, in the Marcellus Shale, and so on. These are energy skids that they use in West Texas. Batteries, controller, 500 watts of solar. This is this is a lattice tower up to a stub pole, 1.5 schedule 40 pipe, about 20 feet up in the air, West Texas. They work great. These tilt down for transportation. Really great system. This is Antarctica. I just wanted to point out that these 2 turbines are at different elevations because this is upwind, and as this turbine in the upwind position captures energy, the downwind turbine, if it's at the same elevation, is going to have a downwind shadowing effect. So you always want to, when you're talking about a multi-turbine installation, you always want to have them at 2 different elevations so that you don't have downwind shadowing effects. Same thing here on this buoy platform. You have solar and wind. This is an Air X Marine. Again, great industrial use for the turbine. 2 different elevations so that you don't have downwind shadowing. Telecom applications are big. Railroad, we work a lot with BNSF. We see a lot of this kind of application. RVs, people will put these things on their RVs. They'll design their own pole kits. This is a mast and stay kit that we sell for the marine applications. They just use this on their RV. And here's Alaska. That wind turbine is spinning like crazy, but the solar panel not doing so great. You can see it's directly wired into the battery bank right there. So hope you learned something in this webinar, and I sure appreciate you guys listening. Again, here's my information. Happy to talk more as you need help.